Hey guys, welcome to Codeforces Every Day Until GM, day 51. We are at 439 subs, so almost there to 500. Want to get there quickly, so I can unlock the community tab and everything. I'm working on a Discord server as well, so eventually we will be able to discuss problems and help each other out. But yeah. Today we're gonna be doing this Div 3 contest that's available in a minute. The goal is 1200. If y'all don't know, after last contest I'm around 1112 rating, so getting to 1200 is very doable. Getting out of this newbie rank, that's the goal for today. But yeah, I think it's doable. I'm locked in. I woke up. I didn't get a lot of sleep yesterday, but you know, whatever. Couldn't really sleep. That's yeah. But yeah, have my desk got standing desk mode. I drank some water. Woke up early. Did my all morning routine, and yeah, hopefully I'm ready. Hopefully I can do at least 3 questions. We're aiming for 4. That's typically how Div 3 goes, right? Like the first 2 questions are kind of trivial. If I can do both of them in under 15 minutes, I'd be pretty happy with that. But yeah, okay. If y'all are excited for this video, be sure to like and subscribe. We'll appreciate it a lot. I'll respond to all comments down below. So yeah, 10 seconds. Let's do this. Got our whiteboard ready, got our IDE ready. Okay, let's go. Eating game. Let's open this up. Okay. Now there are N players. Ith player has AI dishes to eat. They take turns eating the food. Any player can go first. During their turn, if the ith player has finished remaining if the ith player has any dishes remaining, they must eat exactly 1 dish. Then player imod n+1 starts their turn. This continues until all dishes are finished. The last person who eats the last dish is considered the winner. Determine the number of players that can possibly be winners. Okay. So our input is test case t equals int input, and then for in range t, we take an in. Okay, now what is this question about? Once one person starts, the other person ith person has AI dishes, they take turn. In the first test case, player 1 wins for every starting player. Second test case, wait, 10. What is in? The player I mod, and so 1 mod 10. This player who eats the last dish. So 1 just eats everything. Oh, I have one more thing to input. That's why I was confused. A equals list. There's a car outside that's beeping and it's pissing me off. Whose car is that? Get your act together. Okay, so every turn we're eating 1 dish. So the number of turns will be like A1 plus A2 plus dot 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 AN, right? Last person to eat the dish wins. So turns go one, oh, 1, 2, 3, 4, 5, etc. mod in 5 mod 10 is 5 plus 1. So isn't it just like the next person eats like k plus 1, k plus... It's like if k is the player, then turn order is k plus 1, k plus 2, k plus blah blah blah. So isn't it... let me think. Six, 7. Are you serious? So first line of each test case is in, second line is in integers. Why am I just not able to understand what this question is asking? They take turns eating the food. Any player can go first. They must eat exactly one dish. Then this person goes until all the dishes are finished. Okay. So it's like the array. These elements are the number of dishes. So player 1 has to eat 6, player 2 has to eat 7. So we go 1 mod in, so 1 mod number of players, 2 is 1, plus 1 is 2. 2 mod 2 is 0, plus 1 is 1. So it's just every other, the next player gets their turn, right? So what is the total number of dishes? The total number of dishes is this. And then if K starts, the last player is, or the last turn is this. Right? Basically, the number of dishes plus the player that started minus 1 mod in. So we end up with something like S equals sum A. My U has been double clicking lately. I need to go clean that key out. X equals 2 print equals S minus 1 double divide N. Right, and then oh, no, this wouldn't be 2 prints. This would be the minimum number of dishes every player will eat before the final turn. Something like 4i, just like I don't know what to name this. No, sum A. What's going on? T. Oh yeah, players skip turns if they have no dishes, right? Can I just simulate? Let's just simulate. So, fuck this. To print equals 0. Dude, I'm thinking too mathy. I just need to simulate and be done with this problem. Taking too long. Okay, min dishes equals min A for dish in dishes in A. Okay. For I in range in dishes, or AI minus equals min dishes. So now we take turns subtracting 1 until everything is equal to 0. Right. So we can make a set for what are we outputting? Player who eats the last dish. So for well, the sum of dishes is greater than 0 if dish if a player is greater than 0, what am I doing? If sum of dishes is greater than 0 and a player is greater than 0, a player minus equals 1. Player who eats the last dish is considered the winner. Determine the number of players that can be winners. Huh? One winner. I don't understand. Okay, this last case. 2 and 4 can win. Oh, so it depends on the first player. Oh, that makes a lot more sense. Because anyone can eat first. So it depends on who you select as the first player. Right? There's 1 mod 4 is 1 plus 1 is 2. But 2 mod, if I just start here, 2 mod 4 is 2 plus 1 is 3. 3 mod 4 is 3 plus 1 is 4 and then 0. This 1 is 1. So you just always go in a loop. Player 2 wins for every starting player. So, are we just looking at the highest number? And then the count of the highest number? Wait, okay, I don't understand what this question is asking. But now, is it just min dishes equals min a print a dot count m or min dishes or max this? Is this it? This question is so wordy. I don't understand what it's asking me. But okay, for now let's move on because this is not good. I don't remember how long this contest was accepted. That was it. Jeez, why did that take me so long? It took me a good 20 minutes. Alright, next problem. Oh. Okay. AKS LOL is playing a coding game on an array in positive integers. If A is non-decreasing game ends otherwise, choose any single element remove. Determine the minimum possible of elements that can be remaining in the array after the game ends. Input. Just copy all this. It's the same input. Okay. What is this asking me to do? You can remove A is non-increasing, decreasing game ends. So if A is increasing, the game ends. If A is like decreasing and then like sometimes increasing, it ends. Okay. Can choose any digit to remove. Determine the minimum number of elements that can be remaining in the array after the game ends. So until it's not decreasing, we have this minimum of one element can be removed by. It's not if A is not decreasing. If AI is less than or equal to A is not decreasing if AI is less than or equal to AI plus 1 for all. So basically A is increasing or equal. No elements can be removed. So we just check the minimum possible number of elements left once the array is sorted. So we want to keep the smallest like subsequence that is not or non-decreasing. Hmm. So what do we do? We sort it. It's 9. Oh. is so we can pass through once. So turn 1, it's not non-decreasing. What do we delete? We delete 1. Turn 2, not non-decreasing. What delete? We delete 2. It's not non-decreasing. Then we delete 3. So the idea is, let's see, like 1, 2, 4, 3, 5, 7. Going here. We have 1, 2, 4, 3. Of any single element, we need to check if So if A equals sorted A, print in. Now is equal to sorted A. Sorted will be 1, 2, 3, 4. Now we just count the matching, right? So it was like 1. We have sorted A. Pop, pop. 4, 3, 5, 7. Pop, pop, pop. This is 1. Longest decreasing subs. So we're looking for the shortest decreasing subsequence, which best case would be 1, but 6, 7. Is there some trick to this? Like, why can't I think of anything? It's 617. We can pop 7. No, then yeah, and then we can pop 6 if it's 1, 2, 1, 3, 2. This is the minimum case. 1, 2, 4, 3. Then we can pop 1, 2, and 3. If it's 1, 2, 4, 3, 5, we pop 1, 2, 4. No, 1, 2, 5. It's 1. So unless is it just print 1? Can we always boil it down to a single element? It can't be this difficult, right? Like, let's move on to C. I think that's it, but because I actually just can't think of a single trick to it. Oh, it is, bruh. That's crazy. I couldn't think of a single trick to that problem at all. Dude, why do these questions, like, they feel like more thinking than the last contest, but they're actually not that hard, but they're kind of tricking me, you know what I mean? Like, I'm thinking of prefix sums and stuff like that, but they're just not existing. They're just not like what I think about. Okay, it's playing game again. Choose any pair of ints such that... Okay. So, we have the input, and then we still have an hour 33. That's good. Second line, s equals input. Sum of n. Output the answer to each test case. If can win, yes, no. Okay. In one turn, choose any pair of integers such that I is less than j, si equals sj, does not equal star, and sk equals star for... What is star? If no game ends, otherwise sets si to star and sj to star. Wins if only every character is equal to star. So I is less than j, basically. Si equals sj. What does that mean? Yes, okay. So the values of... We're basically saying string I equals string j and does not equal star. And then sk K is any number between I and J and S K equal to star. Okay. So, no. Yes. Because we can choose these two. And choose these two. And then we choose MM. We choose these two. And these two. And these two. So, basically, we want to strip everything. We want to find a palindrome in it. This one is no. No. Bro, what is with these guys in 6-7? So now I wonder if A, B, M, L, L, M is 1. Well, we can select these, then we can select Y is Excalibur bugging out. Reset canvas. Okay, I need a different whiteboard, so I cannot deal with that right now. Okay. So we can only star tubes. Also, we get a yes for this case. Moves you. Oh yeah, this is a palindrome. Basically, we're asking, can we make it a palindrome by removing other palindromes? We want to pop duplicates. And then if the length is 0, then it's possible. It seems like so. Okay, this is hard because it's like if you have an AA, why is nothing working right now? Is it my dark theme? Hello? Paint? I have A, merge, merge, or we can do this. Don't think it matters because at the end of the day we will get 4 stars anyway. Well, we can see the string as sort of like a stack, right? Let me think, how do you actually set this up? Pop, 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 and then if it's empty, then wins, else. So, can we, is it greedy though? I think it is greedy because of this. It doesn't matter how we do it, like, stars. So we can greedily remove pairs. We have a stack. If we have a stack, then we iterate through the string. If stack is not empty, then the last element in stack is equal to the current character of the string, we would pop it, else we would append that character, and then this is just, wait, this is actually pretty simple, I think. It's just some stack math. I haven't done this in a while, but I think it's you define a stack and then you iterate through for char and s, and then you check if the stack is empty or not, and it stack -1 is equal to char. If the stack exists and the last digit in the stack is equal to current character, then we just pop stack dot pop, else we append char. And then if stack print no, else print yes. So if the stack still exists at the end, then there's leftover characters, and we print she doesn't win, else she wins. Okay. Submitting. So we're going to the next problem. Problem D. Portal. Okay, got accepted. Nice. Yeah, that one was so much easier. Bro, these ones even make you think. This C one was like my cup of tea. This is like a classic Like maybe 1,000 rated, less than 1,000 rated. It's like 900 rated. These things like are so hard. Like you're like so thinking based. You have no patterns to go off. It's like you've seen it before or not. Like I don't know. They're not hard, but they're just like, yeah, as I said, you've seen it before or not. Alright, now what are these things? You're given a permutation. What does this look like with my dark reader off? Okay. Colored character. Permutation P of length n. There are also two portals located at position x and y. A portal position I a portal at position I is located between I and ith plus 1 elements of the array. Specifically, if I equals 0, then the portal is located before the first element of the array. If I is equal to n, then the portal is located after the last element of the array. You may perform either of the following operations as many times as you like. Remove the element to the left of one portal and insert it to the right of the other portal. Remove the element to the right of one portal and insert it to the left of the other portal. Jesus, what is going on? Okay. If one operation left we're passing this through this portal to here. Wait, what is this one? Oh, we're passing 4 through this portal and it goes here. Or yeah, 2 through this portal and it goes here. Yeah, okay. 2 operations results in the arrays. Okay, I mean, I understand. Basically, we can perform these operations as many times as you like. This is kind of a long contest. How long was the total time? 2 hours 15. I'm actually making decent pace then. Well, I don't know if it's decent for Div 3, but it's definitely like better than Div 2 pace. I don't know why all my whiteboards decided to stop working today. So T, X, and Y. So it's the first time I've had to map today. Some of them do not exceed 10 to the 5 times 2. The smallest permutation you can obtain. 404. So I watched a YouTube video on portals once. In the first test case, the array is 3, 1, 4, 2, 2 portals using, hold on, what is the smallest? It is a permutation, so it would be 1, 2, 3, 4, right? Lexicographically. So pop 3 over. 3 would be here. 1, 4. Second case. The second case is 2, 3, 1. Really? Pop is 3. I guess so. Yeah, because we can't get 1 over there, so. Wait. This is actually hard. How do you think about this question? So, if you pop to the if you remove, shifts everything, puts it to the immediate right. What kind of data structure can I think about? 3, 2, 1. Where's my? There's like these portals. Pop it here. So we don't actually put these portals in the array. That'd be trolling. What we do end up doing is these portal positions are so 3, 1, 2, 1 and 2. So 1, 3, 1, 2. Dot insert, dot remove. Those are really slow. What? Lexicographically. Lexicographically. So I think what we have to do is, this is probably like the minimal case, right? 3, 1, 2. In fact, let me draw it so that we have an array. Each of these boxes are an array, okay? Let me just draw a ton of boxes. This is the portal box. These are the portal boxes. This is the box before. This is box in the between, box after. And then, so what we do, we take our target, put it, and we are allowed to basically, our target has to be the last index, so 0 or -1, and well, it's actually the digits that we can pop around are in 0 and 4. Oh, technically we can do these two. Or no. 0 and 4. 1, 2, 3. It places it at index 0 and places it at index. Where do the portals go? It's like intuitive I plus 1. So what's touching the portal is 3 and 2. What's touching this portal is 3 is 3 and 2 and 2 and 1. So the portal that's touching is index, the index in the index -1. Touching. So take our touching and we're allowed to put it either at the front or the back of the portal box. So if we take this guy, go through here, put him in the front of the portal box. If we take this guy, put him here, put him at the back of the portal box. Wow. What is this question? I like this question a lot. Do I know the answer to it? No. But I'll try to find the answer to it. So we technically have 3 subarrays. I don't think we use the portal box at all, actually. That's just to keep track of things. 2. Lexicographically. So, okay, so we gotta think about the numbers. Think about the numbers. What? And I kind of want to visualize all of these numbers here. The Scaladrol is not working still. Actually, it is. Is it working or is it not working? Oh, problem E. That's not for me. Where's my Scaladrol? Why is it bugged? Here. Wait. Okay. I don't know that you cannot do that. We clear. Three one four two. Our is it 3142? 3142, yes. So our options become, for the first digit, 3. These will never, actually, that's not true. 1. Push this through. It'll go here. 4 can be the first. 2 cannot be the first. So if there's only one element in block 1, first, anything in A and B. If there is multiple in block 1, let's find a case. One, 3. Let's just make our own case. Like this 1. Maybe I'll give 4 here. So 3 can be the starting digit. 2 can never be the starting digit. 5 can never be the starting digit. 6 cannot be the starting digit. 1 cannot be the starting digit. 4 cannot be the starting digit. So we are checking had. Bro, what is this question? I have no idea where to go. Dude, I have to solve this problem. I solved the other two like way too slow. Other So okay, what are our cases? One. Len. Ben. A. B. Or 0. What does this mean? Circle array. Case 2. What is case 2? This, but this isn't even complete. Like, this is complete. Because then you just choose the smallest. You reorder it to the smallest. I've never seen any question like this. I can't really draw any comparisons. Out of the 200 questions that we've done, on this channel, I'm totally lost. Okay, we have 55 minutes. We can take a look at E. I think we should skip this question because I can't think of shit. And we'll see if E looks like anything we've done before. If not, let's go back to D. Alice Bob playing a game on an array containing n integers. Alice going first. Alice Bob is already more familiar. If A is non-decreasing, the game ends immediately. Otherwise, the player can choose an element x from the array. And positive integers 1 less than y, z less than x, such that x equals yz. Replace x in the array with two elements, y and z. If no such move is possible, game ends. Once game ends, if A is non-decreasing, then Bob wins. Otherwise, Alice wins. Determines who will win the game if both play optimally. First line T, second line is an array. Or is in an array. So we actually just steal the input for this question. So that's Bob. Alice moves first. If the array is non-decreasing, game ends. Otherwise, player may pick an element x, y, and integers yz such that x equals yz, y is greater than 1, z is less than x. Replace any order, no move possible. Game ends. If array is non-decreasing, Bob wins, otherwise Alice wins. For each case, determine the winner, assuming optimal play. Alice will win if both play optimally. Second case, Bob will win. Third case, replace 6 with 3 and 2. Fourth case, Bob wins. They have 6, 7 in here again. Bob wins no matter what move Alice makes. Alice will win. Okay, so what are they actually doing? We have two things they're doing, right? Well, one, we replace x with y and z on a turn. So each one's doing the same thing. So it's a parity type thing. Okay. So when can, let me think. The game ends if A is non-decreasing. That's back. The array is, okay, so this is another, if the array is, if they right off the bat print Bob. Otherwise, Alice can always force a move because if the minimum element is greater than 1, Alice can always make a move, right? Because why? Well, what about 2? Is this true? 2, 3. Pick choose an element X. If X is prime, you're fucked. If X is... No, this isn't true. So if there exists a number that's not prime, a move can happen. N is a number. So do we do a seethe? We're given 3 seconds, 10 to the 5, so 10 to the 5, n log n, or n squared, maybe even, because we're given 3 seconds. Wait, oh, if A is not non-decreasing, Bob wins, otherwise Alice wins. Can Bob force a win? Like, once Alice moves. So, the last case. 6, 7. Bob wins because Alice does 2, 3, 7, and it's non-decreasing. Okay. So it doesn't actually matter. Like, this turn stuff doesn't matter. It's basically checking if the final array is non-decreasing or not. Right? Because if Bob moves, is non-decreasing. It is increasing. If the array is not non-decreasing, then Alice can go first and fuck it up. The only case that Bob wins is when it's non-decreasing by default, and primes, right? Because then Bob will go. Wait, then no, primes doesn't matter because primes means no. If it's all primes, no moves can be made. If it's all primes at the start of the game and no moves can be made, and it's not already non-decreasing, Alice wins. If it's Bob's turn and he makes it so that no moves can be made, and it's not non-decreasing, then it's Alice's turn. So Alice can fuck it up because she can put, if we're replacing with, like, we can pick any Y, Z, and we can flop them in any order, and we can fuck it up. So it's like, I'm just worried about edge cases in this question. I actually think it's something like if sorted else print Alice. Oh my god, where's my shift key? There we go. Now, this one case in the middle here. It's not non-decreasing by default. So, Bob can actually win this, you're telling me. Alice goes. She makes this. What is 8192? 8192 divided by 2 is 4096. 2048. So this is power of 2, so it actually just depends on, well, this will be broken down into 1, 6, 7, 7, 6, 7, 7 prime. Yes. So Alice, Bob. Okay, 2 to the 11 is 2048. So this is 2 to the 13. So there will be 13 2's in between these two numbers. It goes Alice, Bob. So Bob is evens. So it would be Alice's turn. Doesn't matter. Bob wins because it would be non-decreasing anyway. So there's cases where so we check if it's non-decreasing. If yes, Bob wins immediately. Else, check for game end by checking for prime. If there's not a prime, Alice will always put the biggest number first. If the biggest number can be split into smaller numbers. So we need to check if that number is not a power. If A, and it's not, okay. I'm tired of standing, bro. I'm putting my desk down. Iterate through. Hmm. 'm lost. We have 30 minutes. Nine, 8. I have no idea. I feel like I'm just stalling out for the rest of this time. I can't really think of this. I'll try for the rest of the time, but I can't promise I will find a solution. I'll probably just end the video here. It's getting already pretty long. If I do end up finding a solution to D and E, I will let y'all know tomorrow, I guess. I don't really want to just have an hour of me sitting still thinking in this video. So, yeah, if y'all enjoyed the video, be sure to like and subscribe. I'll keep y'all updated in tomorrow's video. Bye.